All right. These are the solutions to the word problems, the applications to do with exponentials and logarithms. So let's work through them together. Some we might have done in class, some we might not have. But if we did them in class, you can go over them a second time. So let's start number one. It says find the amount that results from the investment. So you invested $1,000 at 9% compounded annually. That's really important. After a period of 10 years. So each number is important, but the compounded annual tells me the correct formula to use. So I can use the compound interest formula, which is A equals P times 1 plus R divided by N to the exponent NT. In the question, P represents the principal or your beginning amount, which is $1,000 is what you invested. R is the interest rate as a decimal, so it's 0.09. N is how many times per year it's being compounded, so annually means once a year. And that repeats twice. So you have two N's, so N there and N there, so 1, 1. And then the time, how long is it going to be in for, which is 10 years. And there you go. So put it into the formula, use your calculator. I'm going to use the calculator. Let's see if you can see it on the screen. So it's 1,000. 1 plus 0.09. 0.09 divided by 1 is 0.09. So I'm just going to put in 0.09 to the exponent. And it's 1 times 10, so I'm just going to put 10. And then I'm going to round it to money. So it's $2,367.36. All these use the same formula. So again, compounded semi-annually, so I'm still going to use the same formula. So in this case, again, you're starting with $1,000. The interest rate, 5% as a decimal, is 0.05. And how many times per year is it being compounded? So semi-annually means 2 times a year. So that 2 repeats twice in the formula, and then after 11 years. So again, use your calculator. So 1,000, 1 plus, this one I'll go 0.05 divided by 2, close it. The exponent is 2 times 11, and I get $1,721.57. All right. 14,000 invested at 8% compounded semi-annually. So write down the formula for compounded interest. Substitute in. So the beginning amount is 14,000. The interest rate is 0.08 as a decimal. Semi-annually means twice a year, and then for 4 years, and then use your calculator. So I get $19,159. So $19,159. I'm going to round to 97 cents. All right, let's keep going. Number 4, $480 invested at 9% compounded quarterly after 3 years. So same formula. The original amount is $480. The interest rate as a decimal is 0.09. And how many times is it compounded per year? So compounded quarterly means 4 times a year. And then 3 years. So that's $626.90. Number 5, $12,000 invested, 7% compounded quarterly again after 4 years. So the formula for compounded interest, we started with $12,000. That would be nice. 1 plus the interest rate 0.07 divided by quarterly, so 4 times a year, and then 4 years. So there's the setup. Use your calculator. So I get $15,839.15. Number 6. The Feldmans bought their first house for $15,000. Over the years, they moved 3 times into bigger and bigger homes. Now, 38 years later, they are ready to retire and want a smaller house, like the first one they bought. If inflation in property values has averaged 3.4% per year during that time, how much will the house cost them now? So 3.4% per year is like compounding annually. So once a year it gets compounded. So the formula is this still. So if I read carefully, the original amount for the house was $15,000, so that's P. The interest rate, well, 3.4%. So be careful, that's 0.034. You move the decimal 2 to the left. Per year means once a year, and then it was 38 years later. So how much would that house be worth now with inflation? So then I put that in the calculator. So 15,000. 1 plus 0.034 divided by 1 doesn't change it. And then 1 times 38 is 38. And I get 53,400. It's just to the nearest dollar. So 441. So $53,441. That's how much the house would be worth now. Still a bargain. 7. If Emory has $2,000 to invest at 5% per year compounded monthly, so we got $2,000 as their beginning amount. 5% and it's compounded monthly. That tells me the formula. How long will it be before he has $3,500? That's the end amount. If the compounding is continuous, how long? So there's actually 2 different questions here. There is no way there's enough space to answer any of the questions. So I am going to take out a separate piece of paper. I think you should too in your math notebook. I'm going to make sure it's connected to this packet so you know where the answer is. I'm going to write down number 7 right there on a separate piece of paper. So first question has to do with compounded monthly. So we're starting with this formula for compounded monthly. In the question it says the beginning amount is $2,000. The interest rate is 0.05. Compounded monthly means 12 times a year. And T actually is the unknown. I don't know that number to put in for T. That's what I'm looking for. But the end amount is $3,500. So I need to be able to solve for T with this equation. So let's solve this equation together. So step 1 is to isolate this to isolate the exponential part. So what's in front of the exponential? That's 2,000. So first step is we're going to divide both sides by 2,000. So we have 3,500 divided by 2,000. And we have 1 plus 0.05 divided by 12 to the exponent 12t. Next, we have the exponential part isolated. We need to know how to undo an exponent. So what the inverse of an exponential, so I can solve for t, it's a logarithm. Now I think it's going to be easier to write that base as just one number. So 1 plus 0.05 divided by 12, let's just write that number down. Oh, it's going to be a decimal that goes on forever. So we'll just leave that number then as is. So to write this as a logarithm then, what's inside the logarithm is 1 plus to write this as a logarithm, try again. You start with the exponent, and the exponent is 12t. Then we write down the logarithm. The base of the logarithm is the same as the base, and it's a little bit awkward, but I'm going to use parentheses, and it's 1 plus 0.05 divided by 12. And then what goes inside the logarithm is this number, 3,500 divided by 2,000. And you could put parentheses around that too if you like. So there's the base. That's what's inside the logarithm. the last step is to divide both sides by 12. So there it is. What's on the right side is what I'm going to type into my calculator. So a couple things before I start typing into the calculator. Most calculators, you have to change the base to base 10. So the simple formula to change the base is you take the log of what's inside. So I write down log. I'm changing it to base 10. So the log of what's inside divided by the log of the base. That allows me to type that into a calculator. Then we're going to take that answer and divide it by 12. All right, here we go. So what would that look like in your calculator if you did that? Perfect. All right, so the log button, so just log. Again, if you don't see the base, it's a common logarithm. So 3,500 divided by 2,000. And now I'm going to divide it, again, log. And this is going to be 1 plus 0.05 divided by 12. And I'm going to get an answer. So there's my answer. But I take that answer divided by 12. And there I go. So it says 11 point so on. This is round your answers to 3 decimal places. So I'll do that. So this answer is 11.216. And that's years. So there's the first answer to the first question. Had to do with compounded monthly. So how long would it take? So it would take 11.216 years. Before he has 3,500 in his account, right? And we were just compounding monthly. Now, there's a second part to the same question. So still number 7. And the second part for number 7 was do the same thing, but this time compounding continuous. So that's a different formula. So compounding continuous is A equals PE to the RT. Remember, E in math is a number. Sometimes you remember this by just saying the word PERT. So the numbers we're going to use again. So the original amount was 2,000. The end amount was 3,500. We have E, that's the number. The R, our interest rate, was same interest rate, 5%, right? So 0.05. And what I don't know is T. Now this actually looks more complicated, but actually is going to be quite a bit simpler than the one before. I want to get E by itself, the exponential part, so I'm still going to divide both sides by 2,000. Because they don't go in evenly, I'm just going to leave it as a fraction. Now, the next part after I do that is I'm going to write this as a logarithm to undo the E to solve for T. So to write this as a logarithm, the exponent is 0.05T. The logarithm with the base of E is ln, and then what goes inside there is 3,500 divided by 2,000. So you write it as a logarithm, and then you divide both sides by 0.05. That's it. So use your calculator. So the ln button, 3,500 divided by 2,000, and that's divided by 0.05. 11.192. So, pretty similar answer, right? But it is it takes a little bit less time if it was compounded continuously. All right, so there's number 7. Again, there's no way I left enough room to answer number 7, so it's on a separate piece of paper. All right, next one, number 8. There might be enough room for number 8. Let's see. Austin invested $12,000 in an account, 9% compounded quarterly find the amount after 3 years. So this one actually won't take as much room. So you have your formula for compounded quarterly. In this case, we have 12,000 to start with. The interest rate, 9% is the decimals, 0.09. Compounded quarterly means 4 times a year. And then it's 3 years for the T, and then just use your calculator. So you can see it. So it's 12,000. 1 plus 0.09 divided by 4 to the exponent 12. So $15,672 and 60 cents, right? Around. There you go. All right, turn the page. Always the best way to practice with me is to have the confidence to do it first on your own, then press play and see if it's done correctly. But if you need my help to go step by step, then that's what you need. Number 9, how long will it take for $4,000 to grow to $26,700 and an interest rate of 8.8%? All those numbers I'm going to use, but the key word is compounded continuously. So the formula for compounded continuously is PERT. In this question, your starting amount is 4,000. Your end amount is 26,700. That's a big growth. E is a number in your calculator. The exponent, 8.8. Be careful. That's 0.088 if you move the decimal 2 to the left. And then T, well, that's what I'm solving for. So to get T by itself, we're going to divide both sides by 4,000 to begin with. So we have 26,700 divided by 4,000. Now the exponential is by itself. Now I'm going to write that as a logarithm to undo the exponential. So the exponent is 0.088t. The logarithm with the base e is ln, and then inside is 26,700 divided by 4,000. The last step for t, to get t by itself, is to divide. So we have ln of 26,700 divided by 4,000 divided by 0.088, and now your calculator. So ln 26,700 divided by 4,000 divided by 0.088. And the answer is 21, and it says round the number of years to the nearest hundredth. So that's 2 decimal places. That's 57. So 21.57 years. So I said it would take a long time. That's a big jump from 4,000 to 26,700. So compounded continuously at an interest rate of 8.8%, it would take 21.5 years about. All right, number 10. Suppose that $10,000 is invested in an interest rate of 5.5% per year. And again, the key word is compounded continuously. What is the balance after 3 years? So how much will be in there after 3 years? So the formula for compounded continuously, we have 10,000. We have an interest rate of 0.055. So be careful with that decimal. And then t is 3 years. And that's it. There's nothing to solve for it because all the numbers we need are in the formula and we don't need to rearrange anything. So it's right there. So 10,000 times E. I'm going to press the blue button and ln. There's E in the calculator. So again, if you want to know where it is on this calculator, it's the blue. See where ln is? That blue, e to the x, that's the button. So there it is. So e to the x just means e to some exponent. Our exponent is 0.055 times 3. So how much will be in the account after 3 years? And the answer is about $11,793.93. 11. Kimberly invested $5,000 in her savings account for 4 years. When she withdrew it, she had that much money, $5,797.56. Interest was compounded continuously. What was the interest rate on the account? So this time we're looking for the interest rate. So the formula for compounded continuously, we're told that she started with $5,000. She ended with $5,797.56. E is a number in your calculator. We don't know the interest rate, but we knew it was 4 years it was in. So our goal is to solve for R. Step 1 is to divide by 5,000. I need to get the exponential by itself first. So I divide both sides by 4,000. R times 4 is just 4R, so I'll just write it that way. Then, after you divide both sides by 5,000, we need to write that as a logarithm, now that it's isolated. So the exponent is 4R. The logarithm with that e base is ln, and then inside the logarithms, $5,797.56 divided by 5,000. The last step here is to divide both sides by 4. So to get R by itself, we're going to divide by 4. And then use our calculator. So I get 0.036 and then a bunch of 9s. So I'm going to round that up, and it says round to the nearest tenth of a percent. So we're going to move the decimal 2 to the right so that we understand that answer as a decimal. When you move it 1, 2 to the right there is 3.69 da-da-da. To the tenth means you round to 1 decimal point for the percent. So what was the interest rate? Was 3.7%. All right, number 12. To get $5,600 after 10 years at 6% compounded annually. So I need the right formula. Compounded annually is the compounded interest formula. 5,600 is actually the end amount. I'm trying to figure out what you need to get the present value, the principal amount. P is what I'm looking for. Every other number I'll know. Interest rate, 0.06. Annually is 1 time a year, and then 10 years. To get P by itself, we just divide and then use our calculator. So when you divide, 5,600 is in the numerator. The denominator is a little awkward, but we'll use parentheses. It's 1 plus 0.06 to the exponent 10, because when you divide by 1 or times 1, it doesn't change it. So that's what I'm going to put in my calculator. Divide, make sure I use parentheses when I do it. So it's 1 plus 0.06, close it to the exponent 10, and there you go. So the original amount that was in the account was $3,127 and a penny. Number 13, to get 10,500, again, compounded annually. So compounded annually means this formula. 10,500 is the end amount. I'm looking for the beginning amount. The interest rate was 8%. Compounded annually is 1 time a year and after 5 years. So to get P by itself, I divide. So I have 10,500 divided by. I'm going to use parentheses when I do this. And then use your calculator. So I get the original amount in the account to be $7,146.12. All right, again, this is how we learn, is by practicing. When you get tired, come back to it. Practice independently, then watch the videos the best way. To get $2,000, again, compounded semi-annually this time. So same formula to start with. When it says compounded continuously is the only time you use PERT. Every other time we're going to use this formula. The end amount's 2,000. I'm looking for P. The interest rate is 0.11. Compounded semi-annually is 2 times a year, and that was for 7 years. So to get p by itself, I'm going to divide. So it's 2,000 divided by 1 plus 0.11 divided by 2. 2 times 7 is 14, so I'm just going to do that, make it a little bit easier on the calculator. So 2,000 divided by 1 plus 0.11 divided by 2 to the exponent 14. So the original amount was $945.14. All right. See how far I get here. 15. Same kind of question to get 25,000 compounded semi-annually. So let's write this down. The correct formula. 25,000 is the end amount. The interest rate is 11%. Compounded semi-annually means 2 times a year and then 8 years. So in my calculator, I'm going 25,000 divided by 1 plus 0.11 divided by 2. 2 times 8 is 16 to make it a little bit easier. And that's it. Oh, what did I do? Let's type that over again. I forgot the 1 in front. 1 plus 0.11 divided by 2 to 16. So the amount that was in the beginning was $10,614.53. 16. Start with the formula. 6,500 is the end amount. Interest rate. Compounded quarterly means 4 times a year, and then 10 years. So to get p by itself, we're dividing. So it's 6,500 divided by this. So the original amount was $2,196.04. One more time like this. Probably a good time for you to try. Then press play. Up to you. So we start with 10, or the end amount's 10,000. We're trying to figure out what we started with. The interest rate is 18%, big time. Compounded monthly is 12 times a month, and for 4 years. So to get p by itself, we're dividing. 12 times 4 is 48, just to make it a little bit easier to type in. So we have 10,000 divided by 1 plus 0.18 divided by 12 to the exponent 48. So we started with $4,893.62. 18. Let's see how far I get. Hey, do you want to say hi on the video?
Oh, there's a video?
Right now I'm making a video. You can say hi though.
Hello.
Awesome. Alright, we're on question number 18. I'm not stopping for you guys. I'm already well into the video. So if you want to do this, then you can do this. Okay? So what principal invested at 8% compounded continuously for 4 years will yield that much money? And round your answer to 2 decimal places. So compounded continuously, we use the formula A equals P times E to the RT. That's PERT. We start with, we don't know what we're starting with, but the end amount's 1,190. The interest rate's 8% as a decimal is 0.08. And then T, how many years, is 4 years. So we're going to divide to get P by itself. So it's 1,190 divided by E to that exponent. And then we put it in our calculator. So 1,190 divided by E to the exponent 0.08 times 4. And that gives me $864.12. Try number 19. What principal invested at 6%, compounded continuously, that's the key words, for 3 years, will yield $1,500? So compounded continuously uses this formula, A equals PERT. The end amount is $1,500. I'm looking for the beginning amount. We have 6% interest for 3 years. To get P by itself, we divide, so it's 1,500 divided by E to that exponent, and then use your calculator. So that's $1,252.91. All right, we're going to do 2 more on this video, and then I'm going to do another video another time. So 20. Cindy will require $11,000 in 4 years to return to college to get an MBA. How much money should she ask her parents for now? If she invests at 11% compounded continuously, that's the key words, so she'll have enough money for school. So compounded continuously is A equals P times E to the RT. She needs $11,000, that's the end amount. She's looking to see how much she needs to ask her parents for now, that's the beginning amount. E is the number on your calculator. R is the interest rate, so that's 0.11. And then 4 years, that's the number of years. So I need to get P by itself by dividing. So it's 11,000 divided by E to that exponent, 0.11 times 4, and then use your calculator. That's 11,000 divided by E, and then it's 0.11 times 4 in the exponent, so that's 7,000, and rounded to the nearest dollar would be $7,084. 21. How much money needs to be invested now to get $2,000 after 4 years at 8% compounded quarterly? So compounded quarterly is this formula. A equals P times 1 plus R divided by N to the exponent NT. $2,000 is the end amount. I don't know the beginning amount. The interest rate is 8%. And compounded quarterly means 4 times a year. And it's over 4 years. To get P by itself, we divide, so it's 2,000 divided by 1 plus 0.08 divided by 4 to the exponent 16, because 4 times 4 is 16, and now type it in your calculator. So 2,000 divided by 1 plus 0.08 divided by 4 to the exponent 16. So she needs how much money now? And it's 1,000 to the nearest dollar would be $1,457 she would need now. All right, so those are the first 21 questions. I'll do another video for the next group of questions that you can practice with me. Mr. G Math, over and out.